A space elevator is one of those ideas that sounds ultra crazy at first, but when you learn more about it, it still sounds absolutely crazy. But you can see the upsides. It's exactly what it sounds like, a giant elevator that you get in down here on Earth and you step off of in freaking space. You'd need an anchor on Earth, which would serve as the loading station for the elevator car, a tether stretching into space for the car to travel along, and a counterweight way out in space to keep the tether taut. Designs vary, but it looks like the counterweight could have to be as far as 100,000 kilometers above the Earth, more than a quarter the distance to the moon. Sounds nuts, but for some, it's not just a pie-in-the-sky idea. It's something they're actively working towards. In September of 2018, researchers from Shizuoka University in Japan launched an experiment to the ISS to test the practicality of one aspect of a space elevator. The experiment involves two tiny cube satellites connected by 10 meters of cable, with a small container moving along the cable with a motor. It's a far cry from a full-fledged space elevator, but the goal was to show that locomotion along a cable in space was possible. The experiment is in collaboration with the construction firm Obayashi, which 6 years prior announced plans to build a space elevator by 2050. They're not the only ones toying with the idea. China intends to build one by 2045, and NASA has commissioned studies to look into how feasible the idea is. But hold up, why all the fuss about space elevators to begin with? What's wrong with good old chemical-powered rockets? Well, while we have rocket technology right now to lift payloads and people into space, it's extremely costly. According to SpaceX, it costs roughly $2,700 to put 1 kilogram of cargo into low Earth orbit. An elevator to space would be a massive construction project. Obayashi estimates it would cost $90 billion to build. But once built, by one estimate, it could cost as little as $200 to get 1 kilogram into space. Meaning I would only need $13,000 to get off this planet as opposed to $175,000. A space elevator would open up so many possibilities, like building and launching ships in orbit. Hello, Starfleet. It could make trips to Mars less fuel-intensive because a ship could plummet towards Earth like an Olympic high diver, using Earth's gravity to boost it onto the red planet. Tourists could make trips up regularly. Just get in, listen to Girl from Ipanema, make awkward small talk for a few thousand kilometers, and then get the selfie of a lifetime. Flat Earthers could finally see what we have been trying to explain to them all along. There's literally no reason not to do this, except that we can't do it yet. Sure, we could build many of the components with the materials that we have today, like the anchor on Earth, the counterweight out in space, and the elevator car itself. But the actual tether that holds the whole thing together, that makes it a space elevator, is an extreme challenge. As of today, there's no material strong enough and light enough to stretch 100,000 kilometers into space. That's almost 2.5 times the Earth's circumference. The material has to be resistant to weather, radiation, and orbital debris. The closest thing to that right now are carbon nanotubes, which can be 100 times stronger than steel, but they're difficult to make longer than a few centimeters, which is about 100,000 kilometers short of the goal. Still, Japanese scientists are committed to building a lift to the heavens, and the first stop will be proving an elevator car can travel along a 10-meter cable in space. If you like this video, subscribe, because where else are you going to learn about more cool nanocarbon structures like Schwarzschites? This video, that's where. Carbon nanotubes were discovered by a Japanese researcher, and their expertise is part of why they are more dedicated to building a space elevator than most other countries. Thanks for watching, and I'll see you next time on Seeker.